Hello everyone, welcome to my shop. I'm Robin. Thought I'd give you guys a little update on where things are. I've just been super busy with real work, and hopefully I can get back on a schedule where I can do some more videos, and I've got a lot of stuff coming up that it would just be a crime for me to not shoot videos of and share with you guys. The first one is I acquired a 3-foot by 4-foot master pink AA granite surface plate from my ex-employer. I actually bought this plate when I worked there many years ago. Used it for some special tooling that we did with micro height and different guidance systems and stuff on it. And they let it wear too far, and the relappers came in and started on it and said, you know what, this thing's pink granite is like horrendous compared to black granite to lap, and it's too far out and we're not going to do it. So they said, "Phooey, we'll buy a new one." Set this outside and said, "Do you want it?" I said, "Yeah, I'll take it." So it took me about 2 years to finally go pick it up and bring it here, but it's here now. And this particular video is actually going to be on my take on making a pretty handy surface plate stand. But I wanted to give you a little insight on what kind of path I'm going to be going on here. Behind me you see a new to me Mitsui high-tech 8x18 fully automatic surface grinder. I'm pretty excited about that. And one of the exciting parts is I'm going to do a full rebuild. I'm going to start from the ground up and basically do a foundations of mechanical accuracy tour of rebuilding a machine like this. Obviously it's not a more measuring machine, but this will be a good opportunity to show more pattern scraping, a lot of scraping and metrology measurement techniques, and so that should be really interesting. A full rebuild. We're going to do a lot of things about digital readout placement, looking at a machine and guarding it properly in the beginning, spending a lot of time, what many people would consider an exorbitant amount of time, in preparing this machine with thinking about the guarding and just really making it optimum for what I'm trying to do. And I know from experience that that really pays off, so I'm going to do it here. I will try to give you a rough idea of my train of thought as I'm doing these things. I'm never implying that what I do is the best or perfect or anything else. It's just my train of thought, and may help some people in how to approach problems. There's always a better way, so don't ever take what I'm doing as the ultimate or the end. And if it sounds like that way when I'm talking about it, that's not my motivation. I'm just trying to share things in how having possibly more experience than some people in approaching projects like this. The train of thought process, a lot of people have commented they like that type of video. So not just me, but other YouTube machinist people. I know that their videos that are that style are appreciated. So I'm going to be doing that on that. But when I say foundations of mechanical accuracy, I have to lap this surface plate, and I have cast iron surface plates to lap it. In the process of needing to do this, I have a design for a basically, for a better term, it's a repeato straighteometer, a self-calibrating tool that can measure straightness. I've never seen it, but I'm always cautious about thinking you invented something. If you look far enough and hard enough, probably everything other than some of the new technology has already been done, so it's always a bad idea to think you've come up with something new. But I've never seen it anywhere in any of the metrology things that I've seen for straightness. So I'm going to be covering actually making that gauge, a lot of the design principles that go into making a tool like that. It may fall flat on my face, I may get it all done and it may not work. I'll show that too. If it works great, then so be it. But I think it's a tool that is going to be shown to be really awesome in mapping surface plates. and also in straightness on machine tools. So that's in the works. Also in the surface plate part is how I've used SolidWorks to actually do the topographic maps of the data that you get from your straightness checks, whether you use an autocollimator or whether you use electronic levels, whatever you use to generate your data of the runs of doing your Union Jack pattern on the plate. I will be showing how I've made a SolidWorks model that allows data to just be input, have it actually put dimensions on a drawing, automatically update, and show the topography so that you know what to do when you're lapping. So a lot of interesting stuff involved there. This particular grinder has matched V's, dual V's for the cross slide. So the process of scraping, aligning those, doing the cross slide, I'll be literally taking the entire cross slide off the or saddle, whatever you want to call it, putting on the surface plate. This machine also has ball table tray ways where it has D2 hardened inserts with the V-grooves in them. So as we go, I'm going to end up lapping those V-grooves, accurizing them in place as we build this thing up, just like they do in mechanical foundations of mechanical accuracy. New grade 10 balls. I have to make new cages. I have a lot of interesting things on how I'm going to make the coolant guarding on this. Whole ideas about coolant guarding on surface grinders, especially the way I use surface grinder, kind of like a Bridgeport with a grinding wheel on it. Having more room to work, having more room for exotic fixtures that hang over the chuck a long way, things like that. So should be good stuff. I don't usually take this long babbling about what's going to come up, but I thought it might give you guys an idea of what's coming up. It'll put a little pressure on me to keep putting videos out since I mentioned all these things, so that's always a dangerous thing to do. So this video, like I said, I'm going to cover how I came up with the surface plate stand that I have and the train of thought that went into that. So hope you enjoy it, and let's get to it. I say, hey, need a surface plate stand. All right, hey, I'll just look on eBay. I'll look around, I'll see what's available, and to my dismay, they're, $400, $500, $600 for a very, $700 for a very rudimentary stand that does nothing but hold the surface plate up. And that didn't excite me at all. So I thought, okay, yeah, I'll just buy some square tubing and build them myself. Yeah, my time is valuable, but I kind of enjoy fabricating now and then, and so I thought that'd be fun. So I just sat on that a little bit, and I'm sitting there and thinking, it'd be nice to have drawers in it, and but drawer slides and all that stuff, that's messy. And then all of a sudden I thought, Harbor Freight. Oh, and you guys are thinking, what? Harbor Freight? Yeah, Harbor Freight. And I'm going to show you what I decided on using some Harbor Freight items. So I have a Harbor Freight roll-around box with the top and bottom section that they sell on sale for like $3.50 sometimes. And the quality of those things is astounding. It's every bit as good as Snap-on or Kennedy or any of them. Gauge of material, quality of the drawer slides, everything. It just is really high quality. You just can't believe that it came from Harbor Freight. And I've seen lots of other people that have the same comments. Their roll-around cabinets and stuff, their higher end stuff is really, really good. So I said to myself, oh, wait a minute. Look at these cabinets. Wow, all these drawers ready to go. And see this price, this $4.29? Well, if you wait long enough, as most experienced Harbor Freight buyers know, you wait long enough, they have crazy sales. Well, I bought 2 of these for $3.50 a piece. Now, what makes this perfect? 44 inches long. It's a 3 foot by 4 foot plate. So 44 inches leaves a 2-inch overhang on each end, which is kind of like a clamping ledge. Since this is a non-clamping ledge plate, this plate is 8 inches thick. So it's a thick clamping ledge, but it's obviously still possible to clamp easily on it, and it's sturdier than a clamping ledge because clamping ledges are a lot more flexible than a full thickness plate. So I look at this thing and I say, wow, that's a perfect candidate. But if I put a plate on top of this thing, I'm going to need a step ladder to work on it. So I look at this and say, all right, you know what? I can whack this thing off right here, right at the parting line here where the full length drawer is. Get rid of the full length drawer. The front to back thickness of this is 18. Oh, isn't that nice? 18 twice is 36, the exact width of my 3 foot by 4 foot plate. Weight capacity, 2,633 pounds. Well, the plate's only 1,300, and we're using 2 of these, and I'm going to leave all the wheels on. Yes, all of them won't necessarily touch and bear load evenly, but one of them is enough to carry it. So I say, okay, buying 2 of these. I'm going to whack the top off. I'm going to build a tubular steel frame around here because I have to support the plate on its proper foot locations on the 3-point contact. So I'll build a tubular frame out of 1.5 by 1/8 wall steel tubing. I'll inset it into this frame. I'll weld these all together, paste up the sides to make it look like it's one piece, and I'll be a happy camper because I'm going to have 24 drawers, 12 on one side, 12 on the other. And these drawers are beautiful and they're high capacity, really nice. So tons of space. So what would have been total wasted space underneath becomes a place to store an innumerable amount of metrology tools in this thing with very little work. I will admit that after doing this, the amount of on-the-fly engineering and decisions that need to be made, this was not a trivial project. Not rocket science, but just a lot of little details that required some engineering. Number one was changing where the locking mechanism was from up here, and I ended up putting it in the bottom. So, like I said, not rocket science, but a lot of little engineering required to get that stuff in there. How these things were cut, how I was going to lap the sides to the tubing, just a bunch of decisions on making it come out the best. That took me a lot longer than I thought, but was definitely well worth it. I would do it again. Do it again. So I'm going to show you how we approach this.
Starting out by removing the drawers and the drawer slides, there's a single pop rivet that holds the drawer slides in place. They need to be removed because all the grinding dust and grit would cling to the grease that's on the drawer slides and just ruin them completely. My son and I hacking things up with the disc grinder. Here I have the 4 1/8-inch thick plates stacked for the corner casters. I'm drilling the mounting holes all at the same time. Same thing, but with the 2 plates that cover the joint between the 2 boxes. I'm bolting the casters on over the reinforcement plates. I've got my 5C collet holding my stop in here, putting the nuts in, returning this to the ID of the tubing, and so these press into the tube and have a shoulder. Finish cut. And then I'm going to just do like a 5/1000th undercut here, just visual for a little bit to help it get started in the tube. Here's one of the jack feet. These are 3/4 10 hex bolts. So just turned about 0.3 diameter, faced the nut off, left the 0.3 diameter about 30/1000 so that when these jack down and hit the ground, that they spin on this center part and don't gyrate from hitting on the edges. Here's the nut pressed into the tube. We take the corners of the nut just to make sure it's definitely solid, and we also chilled these every tack. I had my son running back and forth to the sink and cooled them off so that we didn't melt the nylock that's down in there. And then we got our bolt in with blue moly, of course, and we're going to wrench these down in all the way, and this will be our adjuster foot that allows us to jack the table level. I'm cutting the 1.5-inch square 1/8-inch wall steel tubing on the roll-in saw with a 4/6 variable pitch blade. The only reason I can get away with this is because the roll-in saw has the hydraulic feed control, which controls the in-feed per tooth. I'm milling all the joints for the tubular frame because it just makes for a lot less distortion and a more accurate job. Another reason why the roll-in saw is so awesome is being able to do miter cuts in this orientation. My hardened Starrett combination square head super glued to the vise. I'm using a 3x dental mirror here, 3 times magnification. These are really handy for upside down tooling and whatever. But here you can see I'm using it to be able to measure when I'm cutting up to my scribe line for my overall length on these. I'm milling the miter joint to length here, and you saw how I was measuring or seeing the scribe line on the outside with the 3x mirror. And the corncob cutter here gives plenty good enough finish for welding purposes, but cuts freely enough that it doesn't give any issues. Here's a view of the bottom. What we've done is added some 1/8 inch cold rolled stiffener plates just for a little added strength for the casters, but mainly to mount this jack tube. And those are to be able to level the plate and have it rigid so that when we're doing the lapping of the plate to get it aligned, and I'm using precision levels, that this will be stable. All the caster positions are original, and then over here at the swivel end we have the same thing, but we have room for the swivel to clear here. And yes, these swivels can crash, but in reality that's not an issue, as they can always be made to behave, and as long as they're both touching the floor it won't be an issue. So those plates are welded at the edges. You can see they're welded in to just make that relatively rigid, and when you're working on the plate you're doing something where you don't want the plate scooting around. This will make it nice where it'll sit on those 4 feet, and you can tweak the level of the plate completely. Here's the top of the frame. Have the whole top removed that had the full length drawer. All the notches in here for my cross tubes. You can see the frame in the background there. That's just tacked well at the moment. That's 1.5 by 1/8 wall steel tubing. These notches are for that, both on the sides. All this stuff had to be removed. Everything's ready for the frame to be put in and welded fast. You can see the jack feet here on the bottom. The latch used to be in the top section of the cabinet, which I removed. So I wanted to maintain the locking mechanism, if nothing else for a safety standpoint, keeping the drawers from being able to roll out on their own. So here I've moved them to the bottom of the cabinet, remounted the lock mechanism here, and remounted the support for the eccentric shaft, and just drilled a hole to put a smaller piece of cold rolled through there. From the top they used the full cross section of the latching mechanism. So these are mounted on both sides, and then in here we have a pop rivet, and that just held it still while I could take those to the latching rails. So that's how I maintained the locking part of it, and you can see some of the structure here of the walls without the roller slides in. A little paint prep here. Just going to spray the bottoms of these things so that looks a little more professional from the other side. Those are the jack stands, and as you can see here we've got both lock systems in, and yes, I realize that this isn't much of a security measure when it's exposed from the bottom, but I'm more worried about just the drawers falling out, going around a corner and all the drawers flipping out and trying to tip the whole works over. Amazing what a little paint does for the general appearance. Covered up all the areas that were ground as far as rust control, and just made the post look a little nicer for what you can see from the bottom. After some serious Bondo and body work and a lot of sanding and filing and some red Rust-Oleum that happened to match perfectly, I think the finish came out pretty well. Okay, this is the anatomy of a over-designed surface plate foot. So I have a stainless steel backer piece here with 20 thousandths 50 durometer neoprene on the back. Purpose of this is to be able to bond this to the plate without having the difference in coefficient of expansion between this and the plate cause any issues, not cause any shearing forces in the glue line because of the difference in coefficient of expansion, even though it's super small. You're only talking about the difference of 3/millionths of an inch per degree Fahrenheit change. So over this distance and radical changes of temperature, really it wouldn't matter, but it's basically to comply to the plate without any stress risers or any influences at all. But then we need something where this can swivel, and because the frame is not necessarily going to be the same shape every time, because we have jacking legs and it's got some flexibility, we have to be aware that the changes in how this is actually pushed on could vary. So I decided on a captive 95 durometer urethane plug. Now this plug, even though it feels like it's hard as a rock, it's like a hockey puck, would deform significantly with the weight of the plate. It would actually squish out quite a bit. So I made that captive in here such that we have a piston, matching piston, and this basically turns into a hydraulic cylinder with no place for the fluid to go. Because of the durometer of this, it obviously cannot extrude through the few thousandths gap that I have here for my clearance here. This has just a couple thousandths play. But now this will allow this puck to move like this, basically with this acting as if it was a liquid, and maintain height. And it will also give a more consistent, since this is contained, instead of having a pretty significant difference in level of the plate as weights change position on the plate because of the urethane being able to squish and extrude out like a marshmallow, now that it's completely contained, that will be minimized. Now it'll be just the on the verge of zero compressibility of the urethane. So that's the design of that. This actually fits in the tubular ring that you saw on there with the turkite pattern. Here's the turkite. It's been hand scraped to match the pad. This has been ground and cross ground flat, has a nice bevel on the edge so it wouldn't catch, and the turkite is actually designed to be smaller than this so that even if there is any relative motion, there's no edges catching. And then you notice there's two 50 durometer urethane bands on here that actually seat in the bottom of the pocket where it's a straight diameter. And what those do is they centralize this puck so that the differences in coefficient of expansion of the frame and also the geometry of the frame, as it's not necessarily jacked up level, and the twist that we're talking about in the frame might not be the same each time. This is to comply with that. And then these being just in one direction, I'll back up here and show the kinematic arrangement of how those are going to get inserted in the actual stand. So at the single point end of the stand, we will have one sideways so that the loads this way are constrained. Here at this end, we'll have one in the same orientation. This is where we're going to have the 2 feet up here. This has the pads taking loads in this direction so that when I'm lapping on the plate with the big cast iron surface plate lap, that these won't be smacking back and forth. If I didn't have this, the turkite's probably slippery enough that we'd actually have this thing going click, 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 click in the tube. I have a 32nd of an inch clearance from this diameter of the puck to the tube, and that's what these rubber bands that are glued on there take up. Then this one will go with the feet or the pads oriented this way, and that takes care of the motion in this direction when the force is in there. So kinematically, we have 3 points of support for level, and then we also have three points of support for control of rotation in this plane and translation in 2 directions. So we're constrained properly. So these are going to actually go sit in the table, be placed in the table with some CMD extreme pressure lube on the bottoms and on this face. These will go on top like this, and then you'll see that we're going to put super glue on top of high quality super glue, obviously, some Loctite 495. We'll wet the entire surface of this, and then we're going to slowly lower the plate down, keeping it in position until it contacts on here. So all these are held nice and central and aligned, and will drop on, and that'll be that. They'll stay put. The plate will still be able to be removed. It'll lift off just like this, where the puck stays down in there. And the puck can be pulled out if necessary. The puck might actually come with it, since there's going to be extreme pressure lube on here, and it'll probably stick fast. So now we're going to go put them on. I'm rough belt sanding the urethane puck to the approximate thickness before it goes over to the surface grinder.
Urethane pucks, double sticky taped to the surface grinder. It's a 3M tape specifically designed for hard to bond plastics like polyethylene and things like that, so it really gets a good grip on them. Okay, we're going to load the pad up with some gel. Do each pad like that and let it sit in place.
There's the plate, ready to go on the hazard fraught custom stand.
It pays to have neighbors with big tools.
Okay, we're going to use a little pyramid construction principles here. Right now we're sitting on 2.5-inch eye blocks, which I put on there to be able to allow the tow motor forks to get in and out to access this, and for me to have room to put my hands in there to put the support feet in the final assembly. Now we have 1/2-inch increment blocks stacked on each corner. And I'm just going to use a pry bar, actually a die hook, to lift the plate incrementally on each end, drop down 1/2 inch at a time. And in the process, we'll also keep the plate located laterally.
We realized that the 1/2-inch steps were a little steep and causing a lot of axial shift in the plates. So now we've got 1/4-inch steel shims there to be able to go down in 1/4-inch increments when combined with our solid blocks.
The 3 pads with the super glue are in place on the frame, so as I'm letting this down, I have to be very careful to keep the axial and lateral position located properly, so that when this thing touches down, it's not going to move.
There we are, ready to start lapping.
There's the foot super glued in place. The little gap we see just under the large flange is showing that the urethane is not compressed at all. It's supporting the load, and so we're ready to go.
His jack feet were okay, but I realized I needed this angular bracing that I added after the fact, and unfortunately I had to do it laying on the ground because the plate was already mounted and all that, so I had to do all this welding from underneath. And so learned my lesson there. I should have thought ahead more about that, and 2 seconds worth of engineering would have said those posts are going to be awfully squirmy with lateral loads, so I paid for it in the end.
Well, I hope you enjoyed that. Next, we'll be moving on to building the Repeato stratometer, and then from that we'll be doing the lapping, charging this cast iron plate with some diamond powder, lapping this plate into hopefully better than laboratory grade. And if you enjoy this kind of content, please subscribe. If you haven't, tell your friends and share, and I'll see you next time.